Good day, everyone. Our lesson for today is all about solving linear systems, specifically compute linear system, Gaussian elimination, and Gauss-Jordan elimination. Gaussian elimination, also known as raw echelon or raw reduction in an algorithm in linear algebra for solving a system of linear equations. It is usually understood as a sequence of operations performed on the corresponding matrix of coefficients. This method can also be used to find the rank of a matrix, to calculate the determinants of a matrix, and to calculate the inverse of an invertible square matrix. The method is named after Carl Friedrich Gauss. Some special cases of the method, albeit presented without proof, were known to Chinese mathematicians as early as circa 179 CE. To see how a linear system whose augmented matrix has a particular form can be readily solved, suppose that. So if you still remember the lesson 1 that we have talked about in this subject, no, yung lesson 1 natin, which is solving linear equations, ganito yun, din yun. Okay? But in a matrix form. So, as you can see, we have a matrix 1, 2, 0, augmented to 3, and 0, 1, 1, augmented to 2, and 0, 0, 1, augmented to negative 1, represented the augmented matrix of a linear system. Then, the solution is found quickly from the corresponding equation since we already have this one. So, pwede nating gawing ganito lang yan, x sub 1, x sub 2, x sub 3. So, lahat ng nasa row 1, column 1 ay x sub 1, x sub 2, and x sub 3. And this is their equivalence. So, for x sub 3, we have negative 1. Since meron na tayong negative 1 for x sub 3, it's very easy now to find what is x sub 2 plus x sub 3, which is equal to 2, and x sub 1 plus x sub 2, yung 0 wala na yan, so which is equal to 3. So for x sub 2, we want to find the x sub 2 in the second row. So we have to transpose x sub 3, that's negative x sub 3, and the value of x sub 3 is negative 1, so that becomes positive 1. 2 plus 1 is 3. Therefore, the value of x sub 2 is 3. For x sub 1, we have this one, x sub 1. We need to find the x sub 1 by transposing negative x sub 2. It's 2, sorry. 2x sub 2. So we have negative 2x sub 2, and that is equal to 3 minus 6, and that's equal to negative 3. So we have the values for x sub 3, x sub 2, and x sub 1, which is negative 1, 3, and negative 3, and it has a unique solution. Okay, that's how we solve it, if we will use linear system. Now, let A sub AX is equal to B and CX is equal to D to be two linear systems, each of M equations in N unknowns. If the augmented matrix or matrices A augmented to B and C augmented to D are row equivalent, then the linear systems are equivalent. So there is a possibility that the two matrices are equivalent. So that is, they have exactly the same solution. If A and C are row equivalent M by N matrices, then the homogeneous system is AX is equal to 0 and CX is equal to 0 are equivalent also. To understand this theorem and corollary better, let's have an example. The linear system that we have is x plus 2y plus 3z equals 9. So I want you to review the lesson 1 for you to understand this lesson number 7. Okay, so 2x minus y plus z equals 8 and 3x minus z equals 3. So these are our given linear system. So has the augmented matrix of A augmented to B, which is ito yung values ni B, 9, 8, and 3. So 9, 8, and 3. So for this one, we have 1, 2, and 3. So 1, 2, and 3. 2, negative 1, and 1. and 0, no, 3, yung y wala, no? So, 0 and 1. 3, 0, and negative 1. I'm sorry, it's negative 1. So, transforming the matrix to row echelon form, if we will transform this matrix into row echelon form in lesson number 6, no? Naturo ko sa inyo how to do a row echelon form. Pag ginawa natin ito ng row echelon form, ang magiging itsura niya ay ito, no? So, that is 1, 2, 3, and 9, 0, 1, 1, and 2, kasi gumamit tayo ng row echelon form. Kung ano yung ginawa mo dito, yun din yung mangyayari dito, no? So, that is 0, 0, 1, and 3. Now, using back substitution, we now have z equals 3. So, since natapos na tayo sa, kunyari lang ha, kasi wala pa tayo sa solving eh. So, parang dito sa portion na to, pinapakita lang natin na kapag na-solve natin etong given na matrix natin from the linear system into this using a row echelon form, kapag na-solve na natin yan, at nakuha natin na may unique solution for z, okay, dun na tayo pwede mag-solve nun. So, z equals 3. So, what will be the value of y? So, that is y plus z equals 2. And then, lipat mo, that will become negative z. So, ito yan. And the value of z is negative 3, I'm sorry. So, we have 2 minus 3 and negative 1 is the value of y. For this one, we have the x, y, z. So, ito yan. X, Y, Z, no? Pero, kumpleto pa rin naman pala sila. So, we have x equals 9 minus 2y kasi nilipat natin ito, and minus 3z kasi nilipat natin ito. And that will become, the value of y is negative 1. So, negative 1 times negative 2 is positive 2. And for the z, we have 3. So, negative 3 times 3 is negative 9. And this is 0. So, we have 2 as our final answer. Therefore, the value of z is 3. The y is negative 1. X is 2. They are finite. Therefore, they have an unique solution. Kasi pag infinite yung mga solution nila, they don't have unique solution, di ba? There are so many real numbers for the x, y, z. No? Usually, nakukuha yung kapag yung variables ng z ay dalawa. Okay? Pero in this case, as we can see, we have only one value for z, and that's equal to 3. Now, let's have this one. At this point, we have, I think, 4 by 5 matrix. So we have C augmented to D. We have 1, 2, 3, 4, 5, 0, 1, 2, 3, negative 1, 2, 0, 0, 1, 2, 3, and 0, 0, 0, 1, 2. So these are the values. Fortunately, this is already a raw echelon form. Diba? So, maganda siya kasi naka-echelon form na siya, so we can solve. But, we don't have the value for this. Okay, kailangan muna nating makuha, maging 0 yan eh. Kasi ito yung, natin, yung x sub 5. But, we can also solve that, no? Let's say this is an x, since this is the leading one, so that's x sub 4 plus x sub 5 equals 9. Then lipat mo, we have negative 2x sub 5 for the negative 2. So that's x sub 4. That's the value of x sub 4. We don't know yet the value of x sub 5. For x sub 3, we have this one. So x sub 3, nasan ba? Ito. X sub 3, x sub 4, x sub 5, and 7. Then lipat mo yung 2 and 3, becomes negative 2 and negative 3. The value of x sub 4 is 9, negative 2, x sub 5. Ito yan. And then compute. Pag kinompute mo yan, makukuha mo negative 11 plus x sub 5. X sub 2 dito sa taas. So same. 7 minus 2. X sub 3 minus 3. X sub 4 plus x sub 5 equals. What is the value of x sub 3? That is negative 11 plus x sub 5. What's the value of x sub 4? That is 9 minus 2 x sub 5. So, i-add mo lang lahat, i-operation mo lang, makukuha mo 2 plus 5 x sub 5. I hope that's, you know how to do that, right? It's a basic multiplication of functions, or yeah, diba? monomials and polynomials. Okay, madali lang yan. So, the value of x sub 2 is this one. And same with x sub 1. And the value of x sub 1 is negative 1, negative 10, x sub 5. As you can see, lahat sila may x sub 5. So, therefore, x sub 5 is any real number. Kahit anong real number siya, pwede. It can be a negative or a positive real number. Okay? So, the system is consistent. And all solutions are in the form of x sub 1, ito yan. So, sa x sub 1, ito siya, negative 1 minus 10 x sub 5. Let's suppose that r can be assigned any real number. Kasi hindi natin alam what's the value of x sub 5 eh. So, x sub 2, this is a 2 plus 5 plus r. X sub 3, that's negative 11 plus r. And x sub 4, 9 minus 2r. And x sub 5 is any real number. Because if there's a value for x sub 5, ipapalitan lang natin yung x sub 5 dito para makuha din natin yung value ng 1, 2, 3, 4. So, any real number ang gagamitin natin. Kasi, we can have 1 as the value of x sub 5, 2, 3, 4. Tapos ipapalitan lang natin dito yun eh. Diba? So, yan. So, therefore, it has an infinite solution. Doesn't have a unique solution. Okay? So, for this example, it has an infinite solutions. Yung kanina, meron siyang finite solution. That's why it has a unique solution. Dito, wala. Kasi it has many solutions. You can have many solutions as you can. Because x sub 5 can be any real number. Now, let's have example number 7.3. If C augmented D 1, 2, 3, 4, 5, 1, 2, 3, 6, 0, 0, 0, 1, since all the numbers in the last row are 0, therefore it has no solution because we don't have the value for this, diba? That 0 equals 1. Tama? 0 equals 1. So therefore, 0x sub 1 plus 0x sub 2 plus 0x sub 3 plus 0x sub 4 is equal to 1, which can never be satisfied. Okay? It has no unique solution. 7.4, if C augmented to D, kaya dapat dito, balikan nyo yung lesson 1 natin. Kasi if I'm not mistaken, I already discussed this no solution, unique solution, and many solution in lesson number 1, in the first video of this playlist. No? So we have C, D, augmented D. This one, as you can see, it has a diagonal. So echelon. Then 5, 6, 7, 8. Therefore, x sub 1 is 5, x sub 2 is 6, x sub 3 is 7, x sub 4 is 8. Is it correct? Yes. It has a unique solution. May specific answer siya. Okay? So, consider the linear system here. So, the linear system, x plus 2y plus 3z equals 6, 2x minus 3y plus 2z equals 14, 3x plus y minus z equals negative 2. To check your answer, you can use the solving linear system by elimination. Pwede nyo gawin yun para ma-solve yung value ng z, y, at saka x. But, syempre, in this portion, you need to do the echelon form. So, we have A augmented B, ito yan. Ito yung ano natin, no? So, yung 1, 2, 3, ayan, 1, 2, 3, 6, 2, negative 3, 2, ayan, 14, 3, 1, negative 1, negative 2, ito yan. Next, ang target natin ngayong class is maging 1 itong mga to. Tapos maging 0, 0 yan. Okay, yun ang target natin para makuha natin yung value ng tatlong yan. So, we need to add negative 2 times the first row to the second row. So, mag-multiply daw tayo ng negative 2 dito, tapos i-add natin dito para maging 0 yan. So, we have 2, negative 2, ayan siya, no? Negative 2 times 1 is negative 2 plus 2 is 0. Negative 2 times 2 is negative 4 plus negative 3 is negative 7. Negative 2 times 3 is negative 6 plus 2 is negative 4. And negative 2 times 6, negative 12 plus 14 is 2. Kasi ito nang kasama siya sa isa-solve natin. So, ito yung row 1 niya. Yan. Okay? Next. So, we're done here. Next natin gawin is, naging 0 na siya, right? Ito namang isa, gawin natin 0 din. So, we need to multiply negative 3 from row 1, then add to row 3. So, we have 1 times negative 3 is negative 3 times 3 is 0. 2 times negative 3 is negative 6 plus 1 is negative 5. 3 times negative 3 is negative 9 plus negative 1 is negative 10. And 3 times negative 3 times 6 is negative 18 plus negative 2 is negative 20. Ayan na siya. So, ito na yung bago nating row number 3. So, ito rin na bago na rin ito. Okay? Next. Gusto natin ngayon maging 1 yan. Ito 0, tapos 1 din yon. Okay. Let's continue. Next, yung row 3, ito yan, row 3, gawin natin siyang negative. Kunin natin reciprocal niya. That is, I think, i-multiply mo siya. So, that's type number 2. Multiply it by negative 1 over 5. Tama? So, negative 1 over 5 times negative 5 is, that's equal to 1. Negative 1 over 5 times negative 10 is 2. And negative 20 times negative 1 over 5 is 4. So, we have 1, 2, and 4. Here, 0 naman talaga yan. Okay? So, that's for this one. After that, we can now interchange, no? Yung ito at saka ito. Pwede natin silang pag-interchange. So, we have negative 7, magiging baba siya. And ito naman, magiging taas siya. Okay? Parang discardin nyo na rin yan. Okay? Discardin na rin siya kung paano nyo siya gagawin. In this portion kasi, mas madali siya. Kasi kung dito natin siya, in negative 1 over 7, yun yung una nyo naisip, I think. Maghihirapan tayo because we have negative 4 over 7 dito. Tapos negative 2 over 7. So, magkakaroon tayo ng fraction. So, naisip ko na, eto na lang sa baba kasi whole number yung makukuha natin, which is 1, 2, and 4. Okay? So, from here, pwede tayo mag-multiply kay 1 ng 7, tapos i-add natin kay negative 7. So, makukuha natin 0. Ito yan. Then, 7 times 2 is 14, plus negative 4 is 10, and 4 times 7 is 28, plus 2 is 30. So, whole number na naman. So, pwede natin kunin yung reciprocal niya. That's become 1 over 10. So, 1 times 1 over 10 is 1. And, 10 times 1 over 10. And 30 times 1 over 10 is 3. So, ito na yan. Okay, ito na yung value natin. Therefore, the value of z is 3. Okay, ang value ng z natin, class, is 3. Z is equal to 3. So, pwede na tayong mag-substitute. So, for this one, y plus 2z equals 4. And then, z is equal to 3. Pero ililipat muna natin siya. So, we have 2 times 3 is 6. So, magiging negative 6 kasi nilipat natin. So, we have negative 6 plus 4 is negative 2. So, the value of y is negative 2. And for this, we have x plus 2y plus 3z equals 6. Then again, ililipat mo yan. Kaya naging negative sila. I think there's something wrong here. I think this is negative dapat. No? Or ako yung mali. Ang tama naman. So, negative 3 dapat yun. Okay, so it's negative 3. So, we have negative 9, negative 4. Tama naman yung answer niya. 6 plus 4 minus 9. The answer is 1. So, x of 1 is 1, x of 2, x is 1, y is equal to negative 2, and z is equal to 3. Okay? On the other hand, so nakuha na natin ito. Thus, x is equal to 1, y is equal to negative 2, z is equal to 3. Is a solution that has a unique solution using the Gaussian elimination. To solve the given linear system by Gauss-Jordan reduction, okay, we transform the last matrix C of D. Um, kung hindi natin gagamitin ito, itong ginawa natin ito, at magtutuloy-tuloy tayo para ma-solve natin yan, pwede mong gamitin yung Gauss-Jordan reduction. Pero kung satisfy ka na dito, at pwede na natin solve, okay lang. So, we have Gauss-Jordan reduction. So, dito, ang naisip natin, kung ito yung basihan pa rin natin, is negative 2r sub 3 plus r sub 2. So, yung r sub 3 plus r sub 2. So, para maging 0 yan. So, we have, ito yan. So, 0, 0 na yan. So, negative 2 times 1 is negative 2 plus 2 is 0. Negative 2 times 3 is negative 5 plus 4. Tama ba? Ay, negative 6 plus 4 is negative 2. Ayan. Next, gawin nating 0 yung isa. Ito, 0. So, para mangyari yan, kailangan i-multiply natin ng negative 3 ito plus 3. So, ang ating magiging parang equation natin is C augmented to D negative 3 R cubed plus R sub 3, R3 and R to add mo siya to R1. I'm sorry, R1, which is equivalent to R1. So, we have negative 3 times 3 and negative 1, I'm sorry, negative 3 plus times 1 is negative 3 plus 3 is 0. So, we have 1, 2, wala naman kasi tayong multiply dito, 0, 0 yan. So, it's 0. And then, negative 3 times 3 is negative 9 plus 6 is negative 3. Okay? So, ayan yung equivalent niya. Ito yan. And finally, we want to cancel this 2 para maging 0 yan using reduced row echelon form. So, multiply natin si 1 ng negative 2. So, we have negative 2. Ito yan. So, negative 2 times r sub 2, which is 1, is negative 2 plus 2 is 0. And then 0 na to, syempre. And then negative 2 times negative 2 is positive 4 plus negative 3 is 1. So, therefore, so 0, 0 na yan. Ito, 1, 1, 1 na siya using reduced row echelon form. So, we have 1, negative 2, and 3 as a value of x, y, and z. Let's check if they are the same. For the x, we have 1. For the y, negative 2. For the z, 3. So, this is an alternative way using Gauss-Jordan reduction. So, yung na-solve natin dito, kapag nakuha na natin yung row echelon form, pwede natin siyang gamitin na, since meron na tayong value ni z, pwede na tayong mag-substitute. Okay? So, ito yung makukuha nating value ni y tsaka ni x. Ito yan, x equals to 1, y equals to negative 2, and z equals to 3. Pero kung gagamit ka naman ng Gauss-Jordan reduction after mo kumuha ng row echelon form or Gaussian elimination, gagamit ka ng reduced row echelon or Gauss-Jordan reduction. So, gagawin mong 0, 0 itong 2, 3, and 2. Siyempre, masasama ito. And then, ang makukuha mong value is 1, negative 2, and 3. Kapag naging 0, 0 na yan. Which is actually similar lang dito. Okay. So, ang point lang natin dito is pinapakita natin both ways using substitution and using Gauss-Jordan reduction or reduced row echelon form. So, that's all about for solving linear system, computing a linear system, Gaussian elimination, and Gauss-Jordan elimination. With that, thank you very much for your listening.